All right, folks, here we have one of the hardest type of dimensional analysis problems where, in this particular case, we are looking at figuring out how much of a snack that an adult can eat in one day, given a variety of information. So let's take a look at some of the information that we're given here. It says that table salt first contains about 39 grams of sodium in 100 grams of salt. It also says that the Food and Drug Administration wants you to consume less than 2.4 grams of sodium per day. And if a snack mix contains a meager 1.52 grams of salt per 100 grams of the mix, how much of that can we eat in a particular day? I've rewritten the unit conversions or the conversion factors that we can extract from this example. Written right here, and we're going to use that to solve this problem. Keep in mind that the way we solve these types of dimensional analysis problems is to ask ourselves three questions: where are we starting, where are we going, and how are we getting there? Let's answer first the where are we going? And it says we need to know how much snack mix we can eat in a day. So the units of our answer should be in grams of mix per day. Now, there are three different unit conversions here and we need to, the hard part about this, the reason why it's hardish is we don't know where to start. So let's take a look at the units that we've got. If we want an answer that has the denominator day, notice how this one here has the day in the denominator. So that might be a good place for us to start, because then we don't have to do anything to the denominator and just focus on the numerator. Also, if we take a look at mix in the numerator, mix here is in the denominator, and so this conversion factor, if it's going to be used, will need to be flipped somehow, and so we'll need to keep that in mind. Lastly, this conversion factor has two units that aren't going to be useful for us in the end because they don't show up in the results. So they're used in our journey, but they should be used to get rid of other units. Okay, so this is probably going to be used in the middle. This one would be used at the start, and this one would be used at the end. So let's see how this plays out. We start off with 2.40 grams of sodium. I'm going to put a plus in here. You may not know why we're doing that right now, but don't worry, it's just to keep me honest. Okay, now we want to get rid of that sodium, and we see that the sodium shows up right here, but it's in the numerator. We will need it in the denominator, and so this was grams of sodium, and then this is going to be grams of salt. We've got 100 grams of salt in the numerator and 39.33 grams of sodium down there. And that gets rid of that one unit. Excellent. But the answer that we've got right now would be in grams of salt per day, which is not what we're interested in, although it is perhaps a useful piece of information. Let's keep on going because that's not what the question is asking for. We want to get rid of grams of salt. And we see over here that we've got salt in the denominator. We need it in the denominator. And we get grams of mix in the numerator. 100 grams up here. And 1.52 grams of salt there in the denominator. Let's go ahead. We can see that those two numbers cancel out. And we see that our units are grams of mix per day. If we go ahead and crunch these numbers now, multiplying everything through, 401.46 grams, 46 grams of mix. If we take a look at some of the sig figs we've got here, there are 3, 2, 3, 3. I'm sorry, there are 4 right here. So, but looks like 3 units is what we're supposed to keep this to. So let's round this off to 401 grams of mix per day. And if you think about that, 400 grams of mix per day is almost 1 pound of snack mix during the day. So do not do this. My God, that's way too much snack mix. Eat an apple. But this is the right answer to this particular problem. So we will at least get our chemistry right, but we're going to have to run a mile to work off all that darn snack mix. And that's your chemistry teardown for the day.